Hey guys, happy Tuesday. Here's your trivia, GMO trivia for you. First GMO animal that was approved. Didn't happen until 2015, so pretty recent. Um, Here we go. It is a fish, a type of salmon. Scientists mix genes from the Atlantic salmon and the Pacific Chinook salmon. Um, and obviously, there's some pretty big issues with that, as far as like if they got spread to the wild population. And so what they've done is they've actually made all those fish female and sterile. So there you go. There's your little trivia. All right. Today, first off, I kind of changed my mind with the lab. And I'd like you to we're going to do a couple sections of it as we go through it. And will you just turn it in all together at the end, each of those? And I'll let you know when that is and when that's due when we finish all of it. Okay, so like you have the PDF from yesterday that you either printed out and wrote on or did the questions separately. Okay, I'm going to give you a new one today, and this is what we would be going through if we did the lab. So I think it's nice for you to see the steps so you can see how we could transform bacteria and therefore cause them to be a GMO. Okay, so it's going to be 4 pages. It goes through the steps over here so you can look at what we would do. And then it has some questions on the other side, just like before. And I've starred any that I want you to answer. Okay, so as you start up here, you start with a few tubes, and you're going to do some that are going to be exposed to the pGlow plasmid and some that are not, okay, as in a control. All right, so you start with test tubes or not test tube, but microfuge tubes that either say plus or minus pGlow, whether you're going to add them or not. Okay, then you'll add the E. coli bacteria that I would have started for you. Okay, so you harvest a few colonies, you put them in those tubes, and then only the tube that says plus pGlow, you would then also add that extracellular plasmid. Okay, so that was created again with the DNA for ampicillin resistance, arabinose, the ability to break down arabinose, and the glow gene. Okay, so those are all in that plasmid. And again, the arabinose is inducible. So if arabinose is present, it would turn on that operon, and that would include the glow gene. All right. Then we put that on ice. Okay, and we're going to set up 4, and you would have set up 4 test Petri dishes. All right, and in the Petri dishes, I would have actually set them up for you. There's different things. And so LB is just a normal growth medium. And then it tells you whether you're putting pGlow or the bacteria without pGlow. And then some of them have ampicillin in them, and some of them have ampicillin and arabinose in them. Okay, so you can predict what would have happened to those bacteria with or without the plasmid in the presence of those different substances. All right. To actually get the bacteria to take up the plasmid, what do we do again? We heat shock it. And so that was always the most technical part, because you have to heat shock it just right, make it ice cold for a while, and then into warm water for a short period of time, then back on ice. And it basically just freaks out the bacteria, and it grabs a hold of anything. It lets some of those extracellular plasmids in, because bacteria can share plasmids, and lots of times they'll do that in time of stress. Okay, and so they might share a plasmid that has antibacterial resistance or something if you're bombarding it with antibiotics. Okay, and then just some predictions on what's going to happen. Okay, so I will attach this document in a moment. I got to scan it real quick. And you can give those questions a shot. It's such a bummer we don't get to do it, but at least we kind of get to think through the project process. And hopefully I might have some old pictures of this lab. I'll have to look through and see if I have them, and we'll show it and see what should have happened. All right. Have a great day. Bye.